Okay, Assalamualaikum. Now I'm going to present about the activity 1, which is determining the resistance measurement using the Wisdom bridge. So this is my circuit for the first simulation. We have the DC battery of 10 volt here and the resistor of 10 kilo ohm with the 2.2 kilo ohm resistor and unknown resistor of 5.6 kilo ohm and the variable resistor of 30 kilo ohm. And this is the DC ammeter here. So we can run the simulation, and then we need to adjust this variable resistor until we get the DC ammeter is equal to 0 or near 0. So this is the final value that we got, is equal to 0.41 microampere, and the variable resistor is 85% of 30 kilo ohm. So we put it in the table here, and then we need to calculate the RX here, put the R2 and R1 value, and we got the 5.61 kilo ohm. Next is we need to repeat the same process, but this time we need to change the unknown resistor is equal to 1970 ohm, which is referred to my metric number. Now we run the simulation and then do the same step, which is adjust this variable resistor until the DC ammeter is equal or near 0. So this is the final value that we got, is equal to 2.19 microampere and 30% of variable resistor. So we need to do the same, which is calculate the RS value here. So we got the R2 is equal to 9 kilo ohm, and then put the value here, and we get the RS is equal to 1.98 kilo ohm. So that's all for me.
Hello and good day to everyone. My name is Muhammad Shafiq bin Kasmazuli and my matrix number is AE190107, and today I will explain to you about activity 2, which is the measurement of load resistance by Kelvin double bridge. So in this activity 2, we have two process. We have two experiment, which each of the experiment has two process. For process 1, we have switch S in the bridge mode and switch K in the open mode. And the second process is the switch S in the bridge mode and the switch K in the closed mode. So what will happen in the open mode first here? When the switch S is open, our ammeter reading will be show 2 ampere. Our rheostat RS is 6 ohms and our millivolt meter reading is 0 volts. So the resistor of the 4 resistor RB here is 1000 ohms. So when the switch K is in the closed mode, our millivolt meter readings will be 0.0005 volts. So what will happen here is we are going to change our RB value from 1000 to 996.9 and 1015. So after that, after we click the calculate value here, and we found our calculated unknown resistance value is 0.00985. And next, this is the value of unknown resistance Rx. So we use the formula Rx equal to RB over RA times Rs. For this experiment, we use our Rs is 0.01 ohms and our RB is 996.9 and our RA is 1000. So we will calculated we found that our Rx is 0.00997, which our calculated here Rx is equal same to the calculated unknown resistance value in the simulation, which is 0.00985. And next, for the experiment 2, we need to find the calculated unknown resistance value by using the load resistance as between 0.001 ohms until 0.09. So in this experiments, we use 0.001 ohms. And then when the switch K is open mode, we found that our ammeter readings is 2 ampere, our resistor is 6 ohm, and our millivoltmeter is 2.499 volts. And we still use the same value of our resistor for RARB, which is 1000. But when the switch K is in the closed mode, we found that our millivoltmeter reading is 0 volts, and we change our RB here and RB here to 991.6 volts at 991.6 ohms. And then after we click the calculate value here, we found that our calculated unknown resistance value is 0.00100. Then by proving that, we show you the manual calculations. Use the same formula here and take the value, which is now our RS is 0.001 and our RB is 991.6, and we get that our calculated manual for unknown resistance Rx is 0.00099, which we're going to round off it until 3 decimal points, and we get our Rx is 0.001 ohms, which the value is exactly same like the calculated unknown resistance value here when we are doing the simulation. So that's all for me. Thank you.
Okay, now I'm going to explain about the activity 3, which is for the question part. And for first, I'm going to explain about the result in activity 1 and activity 2, which is for activity 1, balance wisdom bridge. And for the first sample, this is source for resistor R1, R2, R3, and RS was set accordingly to the data. And then to make the balance wisdom bridge, the reading emitter must be near 0 by adjusting the R3. So after that, we get the value of 25.5 kilo ohm for R3. Then for the next sample, we choose 1.97 kilo ohm as the value of unknown resistance RS. By keep the same condition, so we get the 9 kilo ohm for R3. And finally, for the value calculated for unknown resistance value, we achieve 1.98 kilo ohm. And next is for the activity 2, which is for Kelvin double bridge. We do the same method by the unknown low resistance was set to 0.01 and the step was adjusted to 6, and ammeter reading is 2 amps. And next, by set the switch as to the bridge condition and switch K to open condition, and the reading value of millivoltmeter that we get is 2.499 millivolt, and the value for calculated unknown resistance that we obtained was 0.01 ohm. And for the other sample, we choose 0.001 ohm as the value of unknown low resistance. And by maintaining the value of rheostat of 6 ohm, we get the same value of ammeter reading as the first sample, which is 2 amp. Okay, next we're going to discuss about the simulated and calculated value of resistance using balance wisdom bridge and Kelvin double bridge. So for the activity 1, we adjusting the R3, the balance wisdom bridge was achieved when the ammeter value was near or equal to 0, while the activity 2, the unknown low resistance was adjusted at 0.01 and 0.001 for both sample respectively. So both the simulate and compute value yield the identical result with the exception of decimal places. And for the next part of we need to justify the percentage error, which is according to this formula. We got the percentage error for the activity 1, and this is for the activity 2. Next question, differentiate. So the wisdom bridge balance the circuit to measure resistance larger than or equal to 1 ohm, where Kelvin double bridge is a modified version of wisdom that measure low resistance value in range of 1 to 0.0001 ohms. So question number 5, the answer is wisdom bridge. And next is for question number 6. For the 6.1, the Kirchhoff voltage and calculate current equation must be used to estimate the value of unknown resistance Rs. If the value of resistor R1, R2, and RT are known, the bridge circuit will produce both voltage and current since the circuit is not balanced. So for 6.2, as the quantity can be measured using an unbalanced system bridge, many physical characteristics such as pressure, temperature, strain must be measured using the unbalanced system bridge. So for example, how to take a temperature reading, and the type of transducer we use is thermistor, which is temperature dependent resistor, and depending on the temperature coefficient. So as a result, the output voltage of the bridge VR will no longer be zero. And that's all for me. Thank you.